String theory in a nutshell. Hello lifeforms, my name is Professor Bread, and today I'm going to be talking about string theory, or what is now called M-theory. This theory is responsible for these equations right here. It is also talked about quite frequently in society, but today I'm going to be explaining it in the most simplistic terms. But before I talk about string theory, I need to explain some of the prerequisites. The universe is made up of four fundamental forces. These forces are gravity, electromagnetism, the strong and weak nuclear forces. These forces exist throughout the entire universe as far as we know, and furthermore, each of these forces has a particle associated with it. These are called bosons, or sometimes called force carriers. For example, the boson for electromagnetism is the photon or light particle. We've also discovered bosons for all the other forces except for gravity. But this is where string theory and other theories like quantum loop theory come in. There should be a so-called graviton particle, but has not been found yet. But what does this have to do with string theory? String theory's purpose is to try and prove that this graviton particle exists. String theory's fundamental principle is that every particle is made up of a one-dimensional string that vibrates at a specific frequency. The different frequencies determine what particle the string make up. For example, one frequency of the string will be an electron, while another one would be a quark, which is a particle that makes up neutrons and protons. This theory is very elegant and explains why particles can behave as waves, as well as particles, and it also helps explain quantum states. But the one-dimensional string isn't the full story of string theory. M-theory, as I mentioned, takes string theory and puts it into an 11-dimensional universe. These dimensions are like the x, y, and z dimensions of a real world, but unlike ours, the reason why we can't interact with them is because of how tiny they are. Humans, when walking in a small hallway, may be able to move in two dimensions, up, down, and forward and back, while an insect in the same room would be able to move in all three dimensions. And this is how the dimensions behave. They're just too small to observe in the macro world, and so they only react with quantum particles at the subatomic level. But the thing that makes M-theory super special is the 11th dimension, which is the idea of supergravity. This idea tries to link the very big and the very small together. Or in other words, supergravity relates general relativity to supersymmetry, which is the relationship between bosons and fermions, or regular matter particles like electrons. So how does this relate back to the graviton? Well, the graviton particle is trying to be explained using the 11-dimensional model, but little progress has been made. Something is missing, but we haven't found that missing link yet. Despite this, string theory has changed the way we can see our universe, and is now being applied in new ways such as in quantum entanglement, which is a story for another time. But that's it for this video of Professor Bread, and I hope I taught you a little bit about some of the mysteries in the universe, and I hope I'll be seeing you lifeforms in the next video.